Welcome to this ADB-D AWS Adult session. In this video, we will look at encryption in transit for autonomous AI database dedicated on AWS, with a specific focus on mutual TLS. The goal is practical. First, we will quickly frame the encryption options available for ADB-D at AWS connections. Then we will move into the demo and show how the mTLS option works for the client connection point of view. This topic matters because database traffic is not just about opening a port and connecting an application. The connection method determines how encryption is negotiated, how the database server identity is validated, whether a wallet is required, and whether the client also presents certificate material during the TLS handshake. My name is Giorgio Bonzi, and I'm part of the Oracle database at AWS Black Belt team in EMEA. Autonomous AI database protects data in transit by default. So the choice is not encrypted or not encrypted. The real design question is how certificate trust is managed and whether client certificate authentication is required. For client connections, the important distinction is between TCP services and TCPS services. TCP services use Oracle Native Network Encryption or NNE. With NNE, encryption is negotiated as part of the Oracle Net connection. This path does not require a TLS wallet, which can simplify client setup. The trade-off is that is not a TLS server certificate validation model. TCPS services use TLS. With TLS, the client validates the server certificate and the session is encrypted using the TLS protocol. Depending on the configuration, TCPS can run as a one-way TLS, where only the server presents a certificate, or a mutual TLS, where the client also presents certificate material from a wallet. And this table summarizes the main connections options. The first option is a TCP with Native Network Encryption, as mentioned, on the default TCP port 1521. This is the lowest wallet overhead option. It is useful when the customer wants encrypted Oracle Net traffic without distributing wallets, but the customer should validate that the negotiated encryption and compliance posture meet their requirements. The second option is one-way TLS with a wallet using TCPS on the default TLS port 2484. Here, the client validates the server certificate using trust material from the wallet. This is the default fit for Oracle Managed self-signed certificates and for traditional Oracle client deployments. The third option is one-way walletless TLS. These still use TCPS and TLS encryption, but the client relies on the operating system or application trustor rather than a runtime Oracle wallet. This can simplify deployment, but trustor governance becomes important. And the fourth option is mutual TLS. This is the option we will focus on in the demo. Mutual TLS uses TLS encryptions and also adds client certificate authentication. In other words, the client proves possession of a wallet-based certificate material during the TLS handshake. That gives the strongest certificate-based client identity posture among these options. But it also means the client wallet must be distributed, protected, and rotated carefully. All these options supports bring your own certificate, and also the default port can be customized during the provisioning of the autonomous VM cluster. But let's start with the demo. I'm now connected to my demo environment, to Oracle Database AWS dashboard. I select my autonomous VM cluster. If I move to the connectivity tab, you have the details about the SCAN listen report for TLS and SCAN listen report for non-TLS. As you see, I have used the default one for both, and super important, I have also enabled the mutual TLS authentication. I jump now to the OCI console, selecting the specific autonomous VM cluster, and this configuration is reflected here. Authentication mode mutual TLS. You can also edit this configuration and you can disable mutual TLS if you want later on. In this way, you will be able to connect through one-way TLS. I want to show you also this tab, Manage Certificates. You can update your database and or the ORDS SSL certificate for your autonomous VM cluster using a system-generated certificate or bring your own certificate. And very important, when you update the database SSL certificate, it will be update the server-side certificate and also the client-side certificate. And each autonomous database is a specific client certificate in its specific wallet. And to download the wallet, you need to select your autonomous database. In this case, I will use this one for my test. I select GBones DB, and from database connection, I download the wallet, providing the password that I configured during the autonomous database provisioning. I have already downloaded this wallet, and it's already available in this EC2 instance where I have installed my Oracle client. This is the TNS admin where I have downloaded the wallet and unzipped the wallet. Let's start looking at the SQLnet.ora. I just modified the wallet location in this file to point to the correct TNS admin, this one. And if we give a look to the TNS name.ora, as you can see, are present all the entry for the non-TLS connectivity, so the protocol TCP for each different services, and for the TCPS protocol connectivity with the underscore TLS, using the default, in this case, 2484 port. For non-TLS, the 1521. So I can now test the connectivity both for the TCP, and I have prepared this script to check check.sql to check the network protocol. So in this case, I'm using TCP connectivity, non-TLS, and as you can see, network protocol TCP. But as mentioned, all the connections are encrypted. In this case, we are using Native Network Encryption. If I execute the connection pointing to the underscore TLS alias, and I execute again the check, as you can see now the network protocol is TCPS. We are using mutual TLS. And I want to show you another interesting thing. In this different directory admin1 underscore new, I have downloaded the new wallet because I have already updated the certificates at autonomous VM cluster level. So I have downloaded the new wallet, and the new wallet includes both the client and server updated certificates. it's very useful to check the README file within the wallet, this one. As you can see, this one is the README file for the original wallet with the expiration date February 8th, 2027 for the client certificate and August 24, 2026 for the server certificate. Because this one has been provisioned the first time when I provisioned the autonomous VM cluster, the client certificate has been configured when I provisioned the autonomous database. But when you renew the server certificate, as you can see in the new wallet README, both the client and server certificates are updated and the new expiration date is the same, the 2nd of August 2027. And very important, the validity of the old certificate is the old certificate can continue to be valid for 14 days to give you the time to switch your client configuration to point to the new one. In this case, I have updated the certificate 3 days ago, and for this reason, I'm able to connect using the old version of the certificate, but also the new one. This one, you see, I'm pointing to the new DNS admin and connecting with the new wallet, and here with the old version of the wallet. And if you don't want to switch your TNS admin location, you can also add in your TNS names an entry, you can see, specifying directly the wallet location in the security part of the connection string. In this case, I'm pointing to the new wallet location, and I will be able, leveraging on the same TNS admin, to point to connect to the database pointing to the new wallet without changing the TNS admin location. This can be useful when you have a lot of different autonomous databases that you want to reach. We are at the end of this video. To summarize, we have covered a summary of the encryption in transit options available on ADB-D at AWS, and then a demo about how to set up mutual TLS for connecting to your ADB-D at AWS. And I leave you with the links to the public documentation related to ADB-D at AWS security topic. Thank you for watching and see you in the next episode. Goodbye all.